Electron affinity. What is electron affinity? E- Electron affinity is the amount of energy released when an electron adds up in the valence shell of an isolated atom to form a uni-negative gaseous ion. So it's a very complicated definitions. That is what it is in your book, but let's make it easy. So if this is an atom, this is an atom, protons are here, this is its nucleus and it's a valence shell. So what electron affinity is the love of electron of an atom. So if this atom has this very electron in its valence shell and here is another electron which you want to add up in this valence shell, so whatever amount of energy you are required are released, whatever amount of energy is released when you are adding this electron into this shell, that energy releasing energy count is what is electron affinity. So what it means is that the love of this electron towards the nucleus, which is positive. So this electron is in love with this positive nucleus. So in love you pay something, and what this electron pays is it pays in the form of releasing energy. It releases energy when it just adds up in this valence shell. So this is an imaginary atom, and it's in its valence shell. When you are adding an electron, what happens is this is its electron affinity. Whatever is releasing the amount of energy, maybe it is called the electron affinity, or the love of electron for the nucleus, or the love of nucleus for the electron, whatever you like best. Trends. In periodic table you will find the trend that in periods it increases from left to right. So from left to right, you know that from left side you will find alkalis, and from the right side of the periodic table, in the right side of the periodic table, you will find that there are, if this is the periodic table, this is the periodic table, you know that there are in this very left side, these are the periods, the horizontal rows are periods. So here are all metals, and on this side you will find non-metals, and here you will find metalloids. The electron affinity, or the love of electron, increases as you move from this direction to this direction, which means that halogens will have the highest love for electrons as compared to the alkali metals. The alkali metals will don't have that much love for electrons to add them up, and halogens will accept an electron, will love to get an electron or to add an electron into its valence shell. In groups, however, from top to bottom, as you move from top to bottom in a group, what happens is the atomic sizes increases, and as the atomic sizes increases, which means that you are adding much more shells to it, and similarly you are adding positive charge to it, but adding much more in this very kind, it is kind of saturated. Down the group the atoms become kind of saturation in the form of saturated form. That's why they cannot add easily electrons, and that is how you will find that generally in a group, when you move from top to bottom, it decreases. As you move from left to right in a period, it increases, and it is actually the love of electrons for the nucleus of an atom, or the love of nucleus of an atom for an electron, which is called the electron affinity. Hope this makes sense. See you in the next video. Take care.